Hello, welcome to the video solution for Edexcel IAL Physics. This is Edexcel Unit 1 June 2019. This is old specification paper I am still using making videos because you know that there is not much difference between the new and the old specification, only some topics. So these old papers you still can use as a practice paper for your new exam. So let's start. Which of the following is a correct unit of viscosity? And that means we need to look for formula for viscosity, and viscosity is in the formula of drag force, which is F is equal to 6 pi eta r V. And we need to find unit of viscosity, so make eta as a subject. So eta is equal to F divided by R V. Remember, I did not write 6 and pi because these two are two constant without unit, so we don't need them in units. So from here you can say that F is the force which is in Newton, and divided by R is the radius in meter. V is the speed or velocity, meter s minus 1. And further, because we do not need unit in terms of Newton, because Newton is nowhere in the option, so let's get rid of this Newton. So Newton is kg meter s minus 2, and divided by meter and meter s minus 1. And of course 1 meter is gone, and you take with this 1 meter up and s minus 1 up, so you can see that this is final simplification will be kg meter minus 1 and 1 s minus 1 and 1 s minus 1 cancel, so s minus 1. So if you see the option kg meter minus 1 s minus 1, so option is B. Question number 2, a specimen of a material was fixed at one end and subjected to a tensile force of 60 Newton. The length of a specimen became 9 centimeter as shown. So 60 Newton force is applied, and due to 60 Newton force the total length is 9 centimeter. The force was increased to 100 Newton and the length of a specimen becomes 11 centimeter. The specimen obeyed Hooke's law throughout. Which of the following was the original length in centimeter the specimen before any force was applied? So we need to find original length. Remember, 9 centimeter is not the original length. This is the length when 60 Newton force is applied. So now you can think that when 60 Newton force, the total length was 9 centimeter, and for 100 Newton force the total length was 11 centimeter. That means 100 minus 60, that means for 40 Newton force, because we have a, the material is obeying Hooke's law, so we have a linear relation. So for 40 Newton force, we have 2 centimeter extension. So for 40 Newton we have a 2 centimeter. So what about 1 Newton force? So 1 Newton causes 2 upon 40 centimeter of the extension. So that means, what about the 60 Newton? So because this is a 60, so what about the 60 Newton? So for 60 Newton we have extension of 2 upon 40 times 60. This is the extension for 60 Newton force, and if you solve this your answer will be 0 0 gone, so 2 or 3, that means 3 centimeter. This is the extension for 60 Newton force. That means the original length is 9 minus 3, that means 6 centimeter. So option is A. Clay can be worked by hand to create pots of various shape and size. Which of the following word describe the property that makes clay suitable for this process? Brittle, ductile, malleable, and strong. Clearly, it cannot be brittle because brittle materials just break or shatter instantaneously as soon as a large amount of force is applied. Like a clay, if clay is dried and you try to mold it, it will break. So in a dried form, clay is brittle. It cannot be strong because if it is strong, it is difficult to mold. And ductile, you know that ductile is all about you apply force to increase the length. So it is something that increase in length. And you know that clay cannot increase in length. So clay cannot be made in a long column. And clearly malleable is you can make a sheet. You apply a force, compress, and you can make a sheet. And as soon as you see the figure, clay is compressed and making a different shape. So in this question, clay is behaving as malleable. Question number 9. A spring is stretched by a force F. The energy stored in a spring is E. The spring is connected to a second identical spring. The combination is stretched by the same force F as shown. Which of the following is the total energy stored of the combination? So suppose the energy stored in one spring, when it was alone, energy stored was E. When you have a combination, the energy stored is E dash. One more thing, during a combination, when you attach a spring in series or end to end, the new stiffness is decreased. In this case, because springs are identical, so new stiffness will be half of the original stiffness. And extension, because each spring extended by the same amount, so we have a new extension in the combination. Delta x dash will be double of the individual one, twice of delta x. So now you can figure out new energy E is equal to half of k dash delta x dash whole square. Now half of k is half of original value of k into delta x dash, and delta x dash dash square twice of the delta x whole square. Clearly you can see that half, I am not just multiplying, I am simplifying in terms of E. So half of k into 4 into delta x square. Clearly this 2 and this 2 is gone. And finally you can rearrange so that you can write twice of this 2 and half of k and delta x square. And half of k delta x square is the original energy. So twice of E. So new energy stored is twice of the E. So your option must be C. Question number 5. Quantities can be either scalars or vectors. Which row of the table correctly describes work and time? Indeed, if you write all the quantities as a vector and a scalar in 2 columns, so this is a quite easy question. You can find in just a matter of seconds. So remember, work is a scalar quantity, time is also a scalar quantity. So that means your option must be D. Question number 6. A man at gym lifted 150 Newton weight through a height of 2.1 meter. He did this 36 times in 122 seconds. Which of the following gives a minimum average power in watts developed by the man? So you need to find power. Remember, power is, in general concept, work done upon time, or power is energy upon time. And remember, in this case, energy is basically mgh. If you see, mg is basically force into the gravity, which is the weight. So in this case, this is weight and this weight is w, which is 150 Newton being lifted upward. So now you can see P is equal to total energy. 150 is the force, but it is lifted by 36 times. So the total amount of force will be 36 into height, which is 2.1, divided by the time taken, which is 122. So 122. So from this, now your option will be B. 150 times 2.1 times 36, and then 122 is the time. So your option is B. Question number 7. The arrow shown represent a force. This is the force. Which of the following shows a correct way of resolving this force into two components at right angle to each other? It's all about resolving a vector into components. So we have two options to look at. You can resolve these vectors either side, either below the arrow or above the arrow. If you draw component below the arrow, so the easiest way, in my opinion, of understanding is you draw a perpendicular from the head like that, and then go to the tail. And then for the arrow, you go back and then mark the first arrow and then keep going. This is the second arrow. So these are two components, horizontal and vertical component of the two force. Now if you compare this diagram with this D option, definitely D cannot be your option because wrong arrows are given. This arrow is in reverse direction. It should be rightward, not the leftward. So D cannot be your option. Moreover, the rest of the diagrams are given the other side. So if you draw component on the other side, so you can see from head, draw a horizontal line and then go towards the tail. And for the arrow, you go back and then draw first arrow and then keep going, draw the next arrow. So now the vertical arrow should be upward, the horizontal arrow should be rightward for the component. And of course, if you see immediately, you will find C is the correct direction of the component. Vertical arrow upward, horizontal arrow downward. While in A, the vertical arrow is a wrong direction, and of course B, both arrow have wrong direction. So option is C. Question number 8. A passenger is standing in a stationary train. The train starts to move and passenger starts to fall. Okay, it's about Newton laws. Direction of movement of train. Train is moving leftward. Which line gives the direction of the horizontal force acting on the passenger and the direction of in which passenger starts to fall? Indeed, you know that according to Newton first law, when object is at rest, it remains at rest. So the direction of the force will be in the direction of the movement of the train. So force will act in the direction of the movement of the train, but due to Newton's first law, the passenger try to remain at rest, a stationary train. That's why it is the law of inertia that passenger is going to fall backward. So as soon as move starts, train moves leftward, so force is experiencing in left direction, but passenger will fall backward. So direction of horizontal force is a forward, so either A or B, cannot be C or D. And of course this is a backward fall, so option will be B. A stationary uniform shelf is hinged to a wall as shown. The shelf is held horizontal by a wire connected to a wall as shown. This is a shelf, this is a wire. Which of the following shows the free body diagram for the shelf? this shelf is will be experiencing three forces. One is the tension in the wire in this direction, and the other one will be the weight. If it is a uniform shelf, so it will be at the center, something like that. This is the W, and there's another force acting by the hinge. So reaction force will be acting from the hinge on the shelf. Reaction force. And because they are held horizontally, that means all forces are in equilibrium. So you need to think a way in which you can find all the three forces are in a right direction. So now if you visualize that whether these three forces, let's check one by one. A, if you draw this vector A, and I'm assuming it is a scale diagram. So if you draw this vector A and join head to tail, then in order to balance, we have this, then it will be balanced. Otherwise this force cannot be balanced. So this is the wrong diagram. So overall diagram is wrong because the third vector is given in a wrong direction, and of course these two also. Now if you see, this one also cannot be, B cannot be our option, because if you join A and B, first of all the length of this arrow is longer than this. If you join this weight vector, then it will be coming something like this. So it will be, it's not head to tail. There is no way that we can join these and we can think of balancing. Option D also, option C is basically, but I'm clearing option D. If you see that if you join tension with the force, so tension weight will be something like that, and the reaction force shown here will be this. So it is incomplete diagram because you have a, you don't have, you need a fourth force to balance. So this is incomplete diagram. But here, if you see, you join, this is the weight, tension, and the reaction force. If you join weight here, and then this R will be joined. Now you see that this is the tension, this is the weight downward, and then this is the reaction force. Then you don't have any resultant force, so you are in equilibrium. That's why C is the option. Question number 10. Which of the following displacement time graph shows a particle starting from rest and reaching a terminal velocity? So if you see, starting from rest and reaching, rest mean it cannot be, of course, if you see, this is a straight line, the gradient is constant there, that means moving with constant speed, and then decreasing speed, and then move with constant velocity. So initially starting from rest, so it should have a 0 acceleration. Now here this is a displacement time graph. So now as soon as the particle starts from rest, so initially it will be accelerating, and then reaching some constant velocity. That means initially gradient will be increasing. Gradient should be increasing. So if you see part D, the gradient is constant throughout. Gradient is constant, so speed is constant. V is constant. So it cannot be option D, cannot be option A. Here, if you see, gradient is decreasing here. So gradient is decreasing. And then this horizontal line shows that it is not moving, no change in displacement. So velocity is 0. So it cannot be B. So in this discussion you can say option is C, but moreover if you see that from the zero rest and then we have a curved up. Curved up mean we have a increasing gradient of the curve, and then after that point something, and then you have a straight line. So in this interval we have acceleration speeding up, and then we have a straight line, so we have a constant gradient. Constant gradient. So speed is increasing and then moving with constant speed. So this is the graph of this terminal velocity, displacement time graph for terminal velocity. It cannot be B. This is sometime you might have a confusion that in text you have seen this graph, but remember this graph is a velocity time graph. If this were a velocity time graph, then you choose option B, but this is displacement time graph. Option is C. Glass is brittle, hard and strong. State what is meant by brittle, hard and strong. A typical definition comes in exam. So brittle is a material that is, does not go any extension, or if it goes in an extension, then there is a very, very, very small extension when you apply force, and if you increase the force, it just shatters. So you say that brittle is a material that shatters immediately if force is applied. Hard, of course, this is a material which is difficult to indent, difficult to bend or something like that. So hard is a material difficult to indent. And strong, the large amount of force needed to break the material. So high stress is required. That's why we call it strong. Remember, there's a difference between hard and strong. So strong means you need large amount of force or large stress to break the bond, to break the material or whatever the material is. When glass is heated, it can be formed into different shapes, such as ornaments or dishes. Explain why the glass needs to be at high temperature for this process. Indeed, if you see glass is a normal temperature, the glass at a normal temperature, which is solid, it is a brittle material. It behaves as a brittle. That means if you try to mold it, it will shatter, it will break. But as you increase the temperature, so temperature is increased, it causes to glass melt down. So molten glass. That means something is flowing. So increasing temperature causing viscosity to decrease. That means material is going to flow easily. And if material is flowing easily, you can mold it, you can reshape whatever you want to do it. So high temperature needed to decrease the viscosity so that it can be molded. And you can write something like that. You can rephrase or you can include something else similar to that in your answer. This is just a model answer. You can write on your own. Question number 12. Newton's third law is often poorly explained. The following notes were written by a student. So we have a block on a bench top. P is the pull on the book to the left. Pull on the book. Remember, these statements are important. These words are really important in Newton's third law. Pull by something on the book. Okay. F is the friction surface to the right. And because arrows is shown on the book, that means this is friction by the bench on the book. By the bench on the book. So in Newton's third law, it is important to understand who's applying force and to whom applying force is applied, or whatever the subject and object is. Okay. A student said that the book moves at a steady speed because F, the friction force to the right, is equal to the opposite force of P, the force pulling on the book to the left. So Student saying that because of force F and the P are same and opposite direction, that's why it is moving in steady speed, and this is a Newton's third law. And we need to discuss this is not an example of Newton's third law. Indeed, it cannot be, this example we cannot use to explain Newton's third law, because for explaining Newton's third law, there are certain conditions for Newton's third law pair of forces. Pair of forces. So number one is, you must understand that forces should be acting in opposite direction. So forces should be acting in opposite direction. So this is true for this example. P and F both are acting in opposite direction, and they have a same magnitude. It is also true. It is also true. So these 2 points are true for P and F, but there are other points that we need to see for the forces to be a Newton third law pair. And the third point is, they must have a same types of forces. Same type of forces. That means either contact force or non-contact forces. Indeed, this is also true. Why? Because F is the friction, which is contact force. P is the pull, which is also a contact force. So these 3 points are valid. But the fourth point is, they must act. The forces must act on different object. Different object. Meaning, if one force is acting on the one object, the other force must act on the second object. In this case, if you see, that's why I said that these statements are important. P is the pull on the book. F is the friction on the book. That means P and F are not Newton's third law pair of forces, because they are acting, both are acting on the book. That means, according to Newton's third law pair, there has to be a Newton third law pair of P, which is pull of the book on something or on some object who's applying P. So there has to be an Newton third law pair of P, which is pull of the book, pull of the book on the object who's pulling the book. So this is Newton's third law. Similarly, this is the friction of the bench on the book. So Newton's third law pair of friction will be friction of book on the bench. That's how we see Newton's third law. So yes, indeed, they are moving with a steady speed, but not due to Newton's third law. Newton's first law is applicable for P and F. So that's how you can explain all these things in the one statement, and you can write something like that. You can pause the video, you can read the statement, and I hope that you will get the idea. Question number 13. The velocity time graph shows the motion of two vehicles, X and Y, along a track at time t equal to 0 seconds. The two vehicles are side by side. Okay. Velocity time graph is given. Vehicle X's velocity is decreasing. Vehicle Y velocity is increasing. Describe the motion of the vehicle X between 0 and 6 seconds. So if you see 0 and 6 seconds, the vehicle X. Initially, vehicle X is moving at a speed of 12 meter per second, and it is decelerating. If you wish, you can calculate the deceleration. So deceleration A is equal to 12 minus 0. And then you can say that 0 minus 6. So your answer will be minus 2 meter. s minus 2. So as the time increases, the vehicle X is decelerating with a constant rate of 2 meter per second square until at 6 the vehicle comes to rest. That's how you can explain the motion. You can show this working if you wish. Part B. Calculate the time at which vehicle Y overtakes vehicle X. Okay, so if you see the graph, vehicle Y initially was at rest. Vehicle Y, which was moving at t equal to 0, and it moves faster but decreasing speed, and vehicle Y is increasing speed. At some time, vehicle Y must overtake the vehicle X. That means because they both start at the same time. So at the times of overtake, time will be same, or the distance traveled by the vehicle Y will be equal to distance traveled by the vehicle X. Now clearly, let's talk about distance of X. So for vehicle X, so distance Sx is equal to, I'm writing this formula for reference, so ut plus half at square, and then you can find, so u was 12 into t. This is the time when vehicle X is overtake. So 12 into t plus half of a. A is minus 2. We have found in the previous question, and then t square. So you can see that 12t and minus 2 is gone. So minus t square. 12t minus t square. This is the distance traveled by car X or vehicle X. Now for a vehicle Y, find the distance. So S is equal Sy. So initial velocity is 0. I'm going to use same formula. Initial velocity of vehicle Y, you see it is 0. So the first term ut is gone, plus half of a. A is the acceleration, and you can find the acceleration from the graph. So you can work out with the acceleration of vehicle Y, which is you can find as clearly you can see that this is 16 meter per second and this is 4. So 16 divided by 4, which is 4 meter s minus 2. This is the acceleration of vehicle Y. So half of 4 into t square. This is the distance. And at time of overtake, s of x is equal to s of y. Distance traveled by both vehicles will be same. Now 12t minus t square is equal to, you can simplify 2 and 2. So you have a 2t square and send this t to the other side. So you have an all term to the other side. So you have a 3t square and minus 12t equal to 0. You can take 3t common. So t minus 4 is equal to 0. 3t, which is t equal to 0. And from this factor, we have a t is equal to 4 seconds. Now this is your answer, 4 seconds. So at 4 seconds here, both vehicles are going to overtake. The vehicle Y is going to overtake of vehicle X. That's how we can find. A video camera is used to film vehicle X. Explain how the velocity time graph can be produced from the recording. A typical question of shooting some incident with the video camera, you can see that if you have a vehicle going on the road, so you can place some marker and then you start shooting the motion, and then from the video you see that you analyze the video frame by frame, and then you can measure the distance from frame and the time. Of course, time is recorded. Time can be measured from frame rate. It is a typical way to find the time from frame rate. Generally, videos are recorded at the 30 frame per second or 25 frame per second. It depends. Generally, these are typical values. So these are for 25 frame per second. If you do 1 upon 30 or 1 upon 25, then they will give you frame for 1 second. And if you are, this is 1 frame, so you can have a distance between these two, and you have a time. Then you can find the velocity, and then you can find for the next step and next, and then you can clearly for each frame, and you can measure the distance from the marker, and then easily you can plot the graph. So that's how you can explain. Question number 14. A Galilean thermometer consists of a set of a glass sphere suspended in a column of ethanol. Each sphere is filled with a quantity of water and is attached to a metal disc to give each sphere a different mass. The masses have been adjusted so that each sphere would float at rest. Okay. When fully submerged in ethanol at temperature marked on the disc, hence the temperature can be deduced from the position of this sphere. Okay, glass tube, ethanol filled, and we have a different sphere and some marking on there. So that means 17, 19, 21, 23, 25. These are the temperature at a different level. On one occasion, the sphere mark 23 was seen to be stationary between the top and the bottom of the column as shown in the diagram. This is sphere 23. Okay, the graph of the density against temperature of ethanol is also shown. This is density and temperature. Indeed, decreasing temperature causes density to decrease. So we have a relation here, and the sphere 23 is floating, stationary. That means weight of the sphere is equal to the upthrust acting. This is the key idea of, remember, floating. If something is floating or at stationary in fluid, weight is equal to upthrust. Okay. Now calculate the weight of the sphere and the disk marked 23. Volume of the sphere and the disk is 1.77 10 to the power minus 6. So you know that we need to find weight. So weight is equal to upthrust. And upthrust is basically density, volume, acceleration due to gravity. So weight is rho Vg. And rho is the density of the sphere. V is the volume. So volume of the sphere is given, which is this. G is 9.81. The only thing we need to find the density of the liquid, and this is all about some certain temperature at 23, because this is sphere 23. So we need to find the density at 23 degrees Celsius, and we have a graph. So you can find the density of the density of the liquid from the graph, and if you see that it will be 20 and then something like 20 divided by 20. So 20, 21, 22 and 23. This is the density that you can find here. And 780 and 790, so clearly this is 788, I guess, because you have a 5, 10, 15, 20. Yes, one line is read as a 1 degree. No, it's not 1. So if you see, I guess first we figure out the scale. It is a better idea. Don't look at this. Okay, so now you see that you have the interval difference is 10. So 10 divided by number of line, which is 20. So that means 0.5. So one line is read as 0.5. So this is 20 and 20.5. This is 21. So 21, 22 and 23. This is 23 degrees Celsius, and then if you go upward, this is where you need to find the temperature. And similarly, if you read that this is 780, again you have a difference of 10 and 10 divided by 20, so one line is again on the y-axis, one line also 0.5, because 10, which is the difference between the reading 790 minus 780, divided by number of lines between the interval 20, so you have a 0.5 as one line. So 780, 785 and 787.5 here, and then this is 788. So at 23 degrees Celsius you have a density of the ethanol as 788. So now you can find W is equal to 788, there is no other unit, okay, into volume 1.77 into 10 to the power minus 6 into 9.81. So weight will be 0.01368 Newton. You can round it off and you can say that weight is 0.014 Newton. That's how you can find the weight. The sphere and the disc mark 23 move downward when the temperature of the ethanol increases. Explain why the sphere and the disc moves downward. Indeed, if you see that the temperature increases, so density is decreased. And density decrease, remember, density decreasing, so upthrust is basically depends on density, volume, and acceleration due to gravity or gravitational field strength. Volume is not changing, G is not changing, but due to temperature, density is decreased. Density decreased, upthrust decreased. So weight is less than upthrust. That's why it is decelerating downward. So we have a weight greater than upthrust. So we have a resultant force downward. So you can imagine you have a greater W, lesser the upthrust. So W minus U will be the resultant force. So that's how you can explain the things. This is the free body diagram, which is already drawn. So complete the free body diagram. You are given a sphere, and they ask you, so because it is moving downward, so of course whenever something is moving, some object is moving in a fluid, downward or upward. In this case, the sphere is moving downward. So it is moving downward, so weight is acting down, upthrust always acts upward. But as the object is moving downward, this is the direction of velocity. That means drag force also acts in opposite direction. So weight, drag force is acting in opposite direction. This is how you can label all the forces. Remember, if something is moving upward, so the free body diagram, moving upward, going upward, this is the direction of velocity. So we have a weight acting down, upthrust always acts upward, and the drag force. Sorry, it's my bad, because it is moving downward. So now in this case, drag force will be acting in downward direction. That's how you see the difference between something moving down in a fluid or going upward in a fluid. But in this case, the disk is moving downward, so this is the free body diagram. Thank you very much. I hope you understand all the question. I will return with the second part of this video. Have a nice day.